Okay, so now we're going to look at the transformations of y is equal to b to the x, or of the exponential function. And the first place I want to sort of start is to say, okay, where are we going to find our good old-fashioned friends, our a, our k, our d, and our c? Okay, well, usually the a value is fairly obvious. Okay, the a value is, well, first of all, we have to notice what our b is, what our base is. That's sort of a new variable that we have in there, because that's going to give us what our parent function is going to be. Okay, we need to look at that to know how we can graph that to start with. So that's actually going to be a beginning step. The second step is to look for a, k, d, and c. Now remember, a and c a is multiplied by the x. Now it's really far away from the x. There's the x right there. Okay? But it's multiplied by out front of the function. Again, multiplied by out front of the function. If the function is the exponent, then it's going to be multiplied by it. But it's not going to be multiplied right beside it here. It's going to be found out here. Because what you do is you calculate the effect of x, and then you calculate, or you change it with a. So it has to be sort of outside of the order of operations. You do the function first, and then you do a. Okay, so you have to do the exponent first, and then you do a. Whereas k is immediately beside x. And so we'll find k up in the exponent. K will be little, and so will d be. Anything that's inside the function is going to be inside the exponent, which means it's going to be little. A little d, a little k. Okay, k, of course, is multiplied. D, of course, is added or subtracted. And remember that we have to factor out the k value to get the appropriate d value. C, as usual, is hanging out on the outside too. So we get the y modifiers on the outsides, and we got the x modifiers on the inside. The horizontal on the inside, the vertical on the outside. Okay, now if we decide to do mapping, we can do mapping from that. The mapping rule is exactly the same. If we want to do a step-by-step, that's fine too. Okay, it doesn't make a difference. Okay, this is just a little bit of a recall. Okay, so if b is going to be greater than 1, all right. If we have a value of y is equal to 2 to the x and our b is equal to 2, then we have an increase for sure. It's a fairly gentle increase, but it does get pretty steep after a while, passing through 0, 1. If we had a b value of 3, it's a little different. It's going to be a quicker increase. Okay, still going to cross at 0, 1, but it's going to take off a lot more quickly. Okay, the key feature is going to be, 0, 1. It's going to be 1, either 2 or 3 or 10. And it's going to be negative 1, a half, negative 1, 1/3, and negative 1, 1/10. That's what's going to help us graph our parent function. These are all b values that are bigger than 1. This is a b value that's going to be a small number, not negative. Okay, because if it's a negative, that's actually a k value. All right. And the b values, we can't have a base that's going to be negative, because if it's negative, it's going to oscillate back and forth depending on whether the exponent's even or odd. Okay, and create this piecewise function that we have. All right, hopefully you saw that when we were doing our exploration a little bit earlier. But either way, if we take a b value of 1/2, that means it's going to be like b is equal to 2, so 1/2 to the x. Okay, or a b value of 1/2. It's going to be like it's a 2, except it's going to be flipped. And that does make sense, because 2 to the negative 1 is going to equal 1 over 2 to 1, or 1 over 2, which means 2 and 1 over 2 are reciprocals of each other, or one is a negative exponent of the other. So whatever this does, it's going to be a horizontal reflection, and so we're going to see it this way. Okay, we'll be talking about those horizontal reflections in a little bit. Take-home message, though, is if it's a half, it's going to decrease, and then decrease gently, crossing at 0, 1. 1/3 is going to decrease more dramatically, and then 1/10 is going to decrease the most dramatically. Okay? So the smaller the number, the larger the decrease. The bigger the number, the bigger the decrease. Because remember, what happens in each x value as we go from 1 to 2 to 3 to 4 is I multiply by b. If I multiply by 2, it gets bigger. If I multiply by 3, it gets bigger. It gets more bigger. If I multiply by 10, it gets more bigger. Okay? If I multiply by a half, it gets smaller. If I multiply it by a third, it gets smaller. And if I multiply by 1/10, it gets smaller. Okay? And as a result, the more dramatic the number, the more dramatic the change. And it's pretty consistent otherwise. Okay? However, all exponential functions do share this key pattern. Remember, at 0, it's going to be 1. At 1, it's going to be b. At -1, it's going to be 1 over b. That's our parent function. And it's a variable parent function because it depends on what my b is. Okay, so what are we going to do? First of all, plot the parent, or determine the table of values for the parent if you're going to use mapping. Okay, that's how we sketch a function. Second of all, determine a, k, d, and c. Third of all, transform the parent function using a, k, d, c in that order because it's kind of basically alphabetical or from left to right, but it's also going to have a and k go first, which have to go first because they're multiplicative, and BEDMAS says multiplication / division goes before addition, subtraction. Okay? If I am going to use the mapping method, again, I do the whole idea, the exact same mapping method. xy turns into x over k. Remember, we divide by k, we don't multiply by k. And we add d, and we add c, and we multiply by a, the y values. And so I would take this, and whatever my a and y are, so this is going to be my setup for every mapping version. For every mapping version that I do for this parent function. Okay? And I'll kind of oscillate back and forth to which technique I'm going to use. All right? But sometimes the mapping ones can take a bit more space, so I may have to grab a scrap piece of paper. There we go. And just in case we're going to need to do that. So that's our setup. Okay? So whether we use mapping or step by step, that's how we're going to graph these functions. So let's do some of these. Okay, now you may want to sort of pause these and have a look at them afterwards because I want to do a lot of examples, and when I'm on the smartboard I can definitely show students this, but in the video it's not going to be as easy to see. So first of all, I've got y is equal to 2 to the x. The first thing I'm going to do is I'm going to create my table of values. -1, 0, 1. Okay, it's a 2, so it's going to be 1, 2, 1 over 2, or 0.5. Okay, so I'm going to sketch my parent function. 0, 1. 1, it's going to be 2, and then -1 is going to be a half, and there we go. That's before I do any transformation whatsoever. Okay? Now, because I'm not doing any transformations in here, so there are none, okay, but it's still increasing, if I want to describe the function in general. And my table of values, my final table of values, is not too crazy. -1, 0, 1. I'm going to go 0.5 to keep it simpler. It's easy to plot decimals, especially if they're terminating decimals. Okay. Now this is 2 to the x plus 1. Okay. That means that I'm going to start with my same table of values, x, y, -1, 0, 1, and it's going to be 1, my b value, 2, and then 1 over 2, or 0.5. Now, what I'm going to be doing is a c value of 1. That's all that there is. There's no a value, there's no k value, there's no d value that's in there. Okay, or the a value and the k value are both 1, and the d value is 0. Okay? So, what am I going to do in this case? I'm not going to do a step-by-step. I'm going to do a mapping here. So what I'm going to do is I'm going to take this 1, which is a c, and I add that to my y value. So 1, that becomes 1.5. 1, that becomes 2. 2 plus 1 becomes 3. And I keep my x values the same. Okay? And I don't need to do necessarily an arithmetic table or do it on a scrap piece of paper. There's my base function right there. I'm just including that in there. Oh, I didn't bring another color. Okay, I'm going to have to pause and get some colored pencils. I'll be back.